This is a tutorial on specifying the angular velocity in MechDev. Let's see how it's done. Let's open MechDev. Here we see the graphical interface of MechDev, and I already have here created a revolute joint in the frame. I want to create a link that rotates with a certain speed, so I go here in the quick build mode and I go here, and with the shift I can go here, exactly here if I want. I need to add a motor. In this case I want to talk about the constant drive. So I add a constant drive and I see, oh, it rotates, and here I can see also the copper curve of the point C, and like this it goes. Okay, I change here and move elements, so here we see we have the different positions. The question is where it is specified now this velocity of this link. We can go here, and here we see here the constant drive, and we see here the constant drive is defined in degrees per second. This is 360 degrees per second. So in 360 degrees it rotates in 1 second. That means in RPM, revolution per minute, if I have 1 revolution per second, then I have 60 revolutions per minute. That means in this case here. And to have a little the background, I show you here what's behind this. The angular velocity here described, it's specified in degrees per second in this release, and the angular velocity can also be converted into revolutions per minute, RPM or N or capital N, or conversely using these relationships that you know very well. 1 revolution to pi is equal to pi, or 1 revolution is equal to 360 degrees. Or here the relation between radian and degrees and minute and second. And the angular velocity in dependency or in function of the revolution per minute is this, that it is times 6, or the revolution per minute as a function of the angular velocity is omega divided by 6. Let's have a look. We go here, and okay, this we know. But now I want to show it in a graph. So I open the graph, I analyze first of all an empty diagram, and in this empty diagram I can define some properties. This properties is defined here. At the x-axis I want to show the time. At the left y-axis I want to show, well, this is the point C. The velocity, I want to show the angle. You see here the angle is 360 degrees, the angle of velocity, and it is here in degrees per second. And also maybe the magnitude of the velocity. So the magnitude of the velocity is here exactly 1800 something. You can compute easily. Okay, just to know where it is, we see here, we can show here the coordinate system, and if I see the coordinate system, you see here, well, here you see this coordinate system, and the velocity is always tangential to this circle, and we have here the angular velocity of 360 degrees, and here the other angular velocity, the magnitude. And maybe I want to add in this graph also the angle of this position. So I go here, go to properties, and well, I make it also as the left side axis, and I add here the position of C, the angle of this, it's given like this. Here we see the angle position like this is 120, or if I see it here exactly, maybe like this. Oh, I don't have it exactly, but it's nearly by 90 degrees. Here you see this is. So the angle is from 0 degree up to 360 degree. This is the angle of this joint C. This is the velocity of the angular velocity of this link or this joint, and this is the absolute magnitude velocity. So, and now we see this, and now maybe the question, if we change this here, so this, well, we want to make changing, so it will be not 360 degrees per second, so maybe we want to have the double speed, so 720 degrees per second. I go here and write here 720 degrees per second, and what happens here, I can here adjust all axes, and I see here now we have 720 rotation speed per second, and this is simulation time 1 second, and here we see, and I see I have 1 revolution in the half time, in the half second. I have also already 1 revolution because I raised the velocity. So maybe now you have the questions. I have a certain revolution per minute, maybe RPM is equal to, let's have 200 revolutions per minute. And then what is here omega? Omega is then very quickly 200 times 6, and this is 1200 degrees per second. So I have to write here, in this case, 1200, and I will do it 1200 revolution per second. And well, here you see all the angular velocity, the magnitude, and here's the angle. And if I choose this angle, you see here 1 revolution we have only in 0.3 seconds. So now you can feel free to add the value of the rotation per minute for your application. And just take into account, these are the equations if you use radians in second, but in this case it is used degrees per second. Thank you for your attention. Danke für Ihre Aufmerksamkeit.